This episode of Real Engineering is brought to you by Brilliant, a problem-solving website that teaches you to think like an engineer. The time has finally arrived. The comment section demanding imperial and metric units has gone on too long. There can only be one measurement system. The British imperial system, like everything British, is based on antiquated units of measurement, like measuring your country's importance by counting the number of countries you have invaded and pillaged. A measurement that made sense 100 years ago, but it's time to move on. Weirdly, the British have mostly moved on from this method of measurement, and it is instead Americans who insist on holding onto it. Well, America, Liberia, and Myanmar, a prestigious trio. Now, I can already hear the people who refuse to wear masks in the comments. There are two kinds of countries, those that use the metric system and those that landed on the moon. You know who led the design team for the Saturn V? This guy. Listen to that deep Alabama accent.
This weight dictates the amount of fuel and the numbers of motors.
An American through and through. Ignore this photo of him. Those are just some German friends he made while on gap year in Europe. Look at all his friends. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8... 9 friends. A popular man. This Alabama native used metric. In fact, he despised British units. So much so that he designed a rocket during his gap year to fly to England to show them how great the metric system was. The Saturn V was designed, like nearly everything in NASA at the time, with a mixture of both metric and imperial units. Just read the mission reports for Apollo 11 for proof of this. It switches between inches and centimeters constantly. It's a mess. Anyone working with this report would have had to be hyper aware of what unit of measurement they were using. Most of the design and science work was done in metric, before being converted to imperial for the manufacturing and operational staff. One of the most mind-boggling examples of this is the guidance computer. It was coded in metric. Meters and kilograms are the language of science. But to ensure the astronauts could intuitively understand what those calculations meant, the displays inside the lunar module had to be displayed in British imperial units. So, even back then, when computer power was extremely limited, the engineers had to waste precious computational time and power to conversion. And this isn't just a waste of computation power. Errors in conversion have led to an insane number of accidents through the years. Some of the most notable being in NASA. In December 1998, the Mars Climate Orbiter took off from Cape Canaveral aboard its Delta II rocket. Over the course of its 9.5-month journey, the orbiter needed to complete trajectory correction maneuvers to bring it into an optimal orbit insertion altitude of 226 kilometers. However, as the time grew closer, calculations showed that the orbiter was entering Mars orbit in a far lower altitude, so low that it was likely going to strike the atmosphere and violently tear itself apart. This is exactly what happened. So, what went wrong? The orbiter was coded with metric units, so the thruster control unit was working with the metric unit for impulse, Newton seconds, but the controller was being supplied with pound force seconds, which differs by a conversion factor of 4.45. A massive discrepancy. A discrepancy that destroyed a $328 million project. In 1983, an Air Canada flight departing from Montreal ran out of fuel halfway to its destination in Edmonton. Why? The ground crew knew 22,500 kilograms of fuel was needed for the flight. They, however, needed to calculate how many liters were needed to be pumped. So, they used the density ratio to convert the weight measurement to a volume measurement, but they used the 1.77 density ratio, which was pounds per litre, instead of the correct ratio of 0.8 kilograms per litre, resulting in less than half the required fuel load being pumped aboard. Luckily, the pilot managed to glide the plane down to an abandoned airfield, but that little boo-boo of a conversion error could have resulted in a catastrophic loss of life. These are two cautionary tales with disastrous consequences. But it tells you nothing of the silent screams into the void every engineer in the world lets out when they are forced to work with both units. It's just an unnecessary pain in the ass we could all do without. This is the reason we need to choose one measurement system. Mixing units not only is tempting fate with conversion errors, but it costs an untold number of hours for scientists and engineers around the world banging their head against tables, when they could be using that time for something more productive. I could end the video there, but we need to really hammer home why metric units are the superior units. So why is it better? Well, let's start with the fundamental unit of measurement. There are 7 base units of measurement, and with these 7, we can measure everything in the universe. Think of them like the 3 primary colors of light. With these 3 colors, we can create any color in the universe by mixing them in just the correct proportions. We can do the same with these fundamental units of measurement. They are time, length, mass, temperature, electric current, chemical amount, and luminous intensity. With these measures, we can describe our universe. Velocity is a combination of length and time, volume is length cubed, density is volume combined with mass. These measurements are the language of the universe. So, let's see how the imperial system handles a very simple one: length. An inch is a standard unit of measurement for length in the imperial system. Let's imagine a scenario. You are designing a railing for a 1 mile long bridge. You, as a skilled and knowledgeable engineer, know that 2 half-inch bolts are more than enough to secure the railing down. The posts of the railing are 6 feet apart. Alright, how many inches are there in a foot? 12? So that's 72 inches. Every 72 inches we need 2 bolts. Our bridge is 1 mile long. How many feet is that? I don't know off the top of my head, and a quick Google search tells me it's 5,280 feet. What's 12 inches by 5,080? That's 63,360 inches. Divide that by 72, that's 880. So we need to order 1,760 half-inch bolts. That felt cumbersome. Why do I need to remember all these numbers? Because imperial is a convoluted mess of measurement units invented by people who married their cousins. That's why. Now, let's see how much easier that is in metric. How many millimeters are there in a meter? It's in the name. Milli, 1,000. Now, how many meters are there in a kilometer? Once again, it's in the damn name, kilo, 1,000. Given a measurement in kilometers but want meters, just shift the decimal place over 3 places. No calculation needed, there is no room for error, it's a simply better system. Even within imperial, you have to constantly convert your units. Ounces to pounds, pounds to imperial tons, which for some reason differs from a metric ton by 1.6%. Again, in metric, there are 1,000 grams in a kilogram and 1,000 kilograms in a ton. In imperial, there are 16 ounces in a pound and 2,240 pounds in an imperial ton. Why? You aren't even following the same conversion conventions as your other units. This is insanely cumbersome. The chances of conversion errors even within your own damn system is high, never mind having to convert to metric. You know what's even more insane? The word for mass and weight in the imperial system is the same. Why? Because the pound was invented before we knew what gravity was. That's why. We just assumed mass and weight were the same thing, when they aren't. So we have to specify in imperial whether we mean pound mass or pound force. I haven't been this confused since I watched Magic Mike. The most ridiculous thing about all of this, every single one of these imperial measurements are legally defined by the metric system. America is already using the metric system, and most of the population is oblivious to it. Freedom, America, guns, pew pew, hoorah! The foot is legally defined as 0.3048 meters. The pound is legally defined by 0.435 kilograms. Why? Because the metric system is run by the International Bureau of Weights and Measures, a neutral international organization whose sole mission is to create a global language of science, who America is a member of. And they have succeeded in an awe-inspiring way. In 2019, the final metric base unit, the kilogram, stopped being defined by human artifacts and is now, like all other metric units, defined by the laws of physics. In 2019, it ceased being defined by this hunk of metal and began being defined by Planck's constant. which is defined as 6.626 by 10 to the minus 34 kilogram meter squared per second. Of course, to use this as a definition, we need ways to define the meter and second. The meter is defined as the length of the path traveled by light in a vacuum in 1 divided by 299,792,458 of a second. Okay, so how do we define a second? A second is defined by the hyperfine transition frequency, which is the frequency of radiation which will cause an electron to jump from two closely spaced low energy states in a cesium-133 atom. Each of the base units are defined like this, using the unchanging language of the universe as its yardstick, or should I say, meter stick. It's a beautiful and inspiring language that transcends the realm of humans, and for that reason alone, you should strive to use the metric system. Understanding the language of the universe is a superpower, and there is no better place to become fluent in that language than Brilliant. Did you know that you can measure literally anything? You can even measure what you don't know, which is something I learned through Brilliant's brand new course, Knowledge and Uncertainty. You intuitively know that knowing the weather 30 days from now is more uncertain than the result of a roll of a dice, and a roll of the dice is more uncertain than a coin flip. But why? We can't physically measure them with a ruler or scale. Being able to quantify uncertainty and know how to decrease it with information is an incredibly valuable skill, and this course will teach you everything you need to know. Or, if this course is not your flavor, you could learn math with the people that invented it with their other brand new course, Math History. This journey of problem solving unpacks the first algorithms for finding primes, the original ideas behind imaginary numbers, and how ancient patterns have made their way into modern mathematics. These are just two of many courses on Brilliant that will improve your ability to understand the world around you. If you are naturally curious, want to build your problem-solving skills, or need to develop confidence in your analytical abilities, then get Brilliant Premium to learn something new every day. Brilliant's thought-provoking math, science, and computer science content helps guide you to mastery by taking complex concepts and breaking them up into bite-sized, understandable chunks. You'll start by having fun with their interactive explorations, and over time, you'll be amazed at what you can accomplish. As always, thanks for watching, and thank you to all my Patreon supporters. If you'd like to see more from me, the links to my Twitter, Instagram, Discord server, and subreddit are below.